You see this nice little car? Let's say it's moving with an initial velocity u and a constant acceleration a. It moves for time t. Let's pause for a moment and move beyond admiring the car. After time t, let's say it has reached a velocity of v and it has covered a distance of s. Now, let me give you an equation. V squared minus u squared is equal to 2as. I'll help you derive this, but using the velocity time graph. So first, let's draw the velocity time graph. There it is. Look at it carefully. What do you see? Initial velocity u, that is mo, which is of course also equal to qp. Final velocity, that happens after time t. Look at the graph. It is or or np. Time t is op, as you can see from the graph, which is also equal to mq. Now this straight line mn, can you see that? This is the critical line. It represents the velocity time curve. Now in this case, it happens to be a straight line. Now the distance covered by this car, how do you find that out? That is nothing but the area of the trapezium OMNPO. Can you see that? So if you want to find the distance, you need to find this area. So shall we? Back to some maths. What is the formula for the area of a trapezium? Half into sum of the parallel sides into distance between them. Fine. Half into OM plus PN, they are at the parallel sides, into OP, the distance between them. Now, OM is U, I told you that. PN is V and OP is T. So let's go ahead and substitute. So the distance S is half into U plus V into T. But remember the equation that I told you about in the beginning? There was no T there. We need to eliminate this T. And how can we do that? Let's look at our velocity time equation. V equals U plus AT. Now, if I ask you to find T from this, that should be simple maths. T is V minus U by A. Now, you got this value of T. We substitute this in our first equation. And what do we get? The distance S is half into U plus V into, instead of T, we write V minus U by A. Now it is simple juggling around with these variables. And we get S is V squared minus U squared by 2A, which obviously means V squared minus U squared is 2AS. And you know what? This is the third equation of motion. This is also known as the position velocity equation of a uniformly accelerating body. You see this car on the screen? Now at a point of time t1, this car starts with a uniform velocity of u, moves with constant acceleration till our point of time, which is of interest to us, that is t2. Now let's represent this motion of the car on our time velocity graph. There we go. So m is the point at time t1 and n is the velocity at time t2. Fine. Now the task that we have is, we need to find the total distance that it has covered. And we need to use our graph for that. Now it's a velocity time graph. So this trapezium QMNP, yes, the area of this trapezium is what will give us the distance. And how do we find the area? Simple geometry. Area of this rectangle MTPQ plus area of the triangle MNT. Right? Now, if you look at the graph, initial velocity u is equal to mq, which is equal to tp. Fine. And pq is t2 minus t1, which is also equal to mt. Now, let's first look at our rectangle. What is the area of this rectangle? Simple. U, that is one side, into t2 minus t1. That is simple. Now, what about the area of this triangle? Area of the triangle, half base into altitude. That is half into mt into nt. Now, mt, if you look at the graph, is t2 minus t1 into nt. How do we find nt? concentrate. NT is NP minus TP. You agree with me? Now TP is, yes, U. And what is NP? NP actually is the final velocity at point T2, right? So we use our equation of motion, U plus AT. That's what V is. So U plus A into the time interval is T2 minus T1. So this is NP, U plus A into T2 minus T1. And from this, we subtract TP, which is U. So we get A into T2 minus T1 as NT. Now we substitute this in our triangle area. So half into T2 minus T1, that is the base, into altitude, that is NT, which we found as A into T2 minus T1. So what do we get? Simplify it further. S, the distance, is equal to U into T2 minus T1 plus half A into T2 minus T1 squared. Now look for T1 equal to 0 and T2 equal to T. What happens to the equation? Yes, it gets reduced to S is equal to UT plus half AT squared, which happens to be our second equation of motion.